When we use water in households and industries, it becomes contaminated with scraps of food, refuse, and other kinds of impurities. In the resulting wastewater, we have collected organic matter and nutrients such as phosphorus and nitrogen. The organic matter may be dissolved in the water or appear as solid particles. When these elements end up in a lake, river, or ocean, the oxygen content in these waters is affected. The organic matter immediately starts to consume oxygen in the water, resulting in an oxygen deficiency, which in turn leads to the death of fish, so dependent on dissolved oxygen for life. These problems are actually caused by an unnaturally high consumption of oxygen. But if nutrients, such as phosphorus or nitrogen, are discharged into a water, they provide a food source for algae and plankton. This new biomass is in fact organic matter, and when this decomposes, we have an additional consumption of oxygen. Small quantities of nutrients can cause large increase of biomass, substantial oxygen depletion, and extensive damage to a particular body of water. The effluent from a given wastewater treatment plant will have varying impact according to the nature of the water receiving it. Outlets of organic matter are sometimes harmful. At other locations, a discharge of phosphorus or nitrogen could cause extensive damage to the environment, since it can initiate biological growth. It is therefore of vital importance that the regulations for discharge permits and choice of purification methods comply with the ecological prerequisites in the area. The pollution can be removed by different methods, and a number of processes have evolved over the years. Today, we apply reliable techniques to achieve the desired result. Mechanical treatment plants use sedimentation to separate particles. This is a simple process where large particles sink to the bottom and form sludge. Since only 1/3 of the organics will be removed by this process, biological or chemical purification is supplemented in order to meet increased requirements. In biological treatment, microorganisms feed on the available organic matter. These organisms proliferate, and the surplus is separated as sludge. Air is blown into the water to sustain the bacteria. Chemical treatment utilizes a coagulant such as iron or aluminium. Then solid organic matter and phosphorus are precipitated into larger pieces which are separated as sludge. With the advent of chemical purification in drinking water treatment, great progress has been achieved in public health. Today it is the world's most commonly used process for potable water production. Let's compare these methods. We start them at the same time and discover that chemical precipitation cleans the water very rapidly. Less than 15 minutes after the initiation of the process, we have clean water. With the biological process, it will take 3 hours to obtain the same result. Biological purification lasts a comparatively long time and is dependent upon the effectiveness of the microorganisms. Chemical and biological treatment work in different ways and achieve different results.